Here's a warm frontal example on the upper graphic here. As warm air is overtaking cold air, warm air is less dense, and cold air is a little bit more dense. So as the warm air tries to push the cold air out of the way, it actually rides up and over the cold air. It's actually almost like a little lid on the cold air. And the air will rise, creating clouds and precipitation. The cold front situation on the bottom here is where your cold, dense air is pushing into warm air, and you'll create showers and precipitation where that cold air is progressing eastward, or so to speak, east to the northeast, depending on the storm system. But basically, we want you to know that as these air masses move, you create frontal boundaries, and we monitor where those frontal boundaries are because weather is generated along frontal boundaries. All right. Fronts are three-dimensional, as you saw in that graphic. 3 dimensions. So you have to understand that the air mass changes as you go up into the atmosphere, and then from north, south, east, west as well. Warm fronts, clouds and precipitation usually occur over a wider area, and it's a little bit slower rising of air. So you get lighter precipitation, not as many strong thunderstorms, and they'll last for half a day to a full day sometimes. Cold fronts, it's a more sharper rise. The air is pushed upward more rapidly along the leading edge of a cold front, and you'll get some really strong thunderstorms at times, and those storms can last from a few minutes to an hour or two, and you can get very heavy rains, hail, sometimes tornadoes. So those cold fronts are generally what produce the more damaging weather that you see out there. And then the wind directions are kind of what derive the different sides of the front. You'll have southerly winds ahead of a cold front and northwest winds behind a cold front, so to speak. So we'll analyze that as well. But there are air directional changes across the frontal boundary. That's one of the reasons one of the ways we define a frontal boundary. Some fronts don't have a lot of precipitation or even clouds. You'll have stationary boundaries that really don't have much moisture. Even cold fronts can have little moisture at times, and there'll be no more than a wind shift or a temperature or humidity change. So it's not a fact that all fronts will have precipitation, but most of them do. In the summertime, sometimes you'll have a cold front go through, and it seems like the temperature is almost the same in front and behind, and the difference will be the humidity will drop. You'll have a drier air mass come in, but not necessarily colder. So there's all sorts of changes that can occur, and even as subtle as just the humidity dropping and the temperature staying the same. So fronts are anchored to low pressure systems on a weather map, and we just define as the cold air is overtaking warm air, we just attach the low cold front to the low, usually drawing it straight south, and just showing you where the progression of the cold air mass is in relation to the warm air that it's overtaking. And thunderstorms and severe weather usually occur in that warm, humid air ahead of the cold front, between the cold and the warm front, because the warm front will extend east from the low and the cold front will extend south. When we analyze coastal areas, you'll get sea breezes and lake breezes that bring cold, cool air off of the lake, and you'll have major temperature changes over a couple of miles inland from a shoreline. It's pretty amazing how quickly air can become cold as you get closer to a lake. Same thing in winter. Heavy lake effect snows come off of the Great Lakes as cold air flows over the warmer water and draw moisture from the lakes and deposit it downstream on the eastern and southern shores of the lake. In the central United States, most common area for tornadoes, especially in the spring as we transition from spring to summer. Thunderstorms are really common, especially in the south. Florida especially is one of the higher frequencies of thunderstorms. Western high plains as well as eastern slope of the Rockies. As air rises up the Rockies, create thunderstorm activity there. Thunderstorms generally not as prominent across the Pacific coast and the western United States and in Hawaii. Just not a lot of air mass change there. Air mass changes cause thunderstorms, cold air overtaking warm air. So without those major changes in air mass, you usually don't generate as many thunderstorms. Tropical storms and hurricanes develop, of course, over the ocean, and they're primarily in the late summer through fall, when the water becomes the warmest. The globe gets heated throughout the summer, and then that heat is utilized by the hurricane systems in the late summer and fall. West Coast doesn't get a whole lot of tropical storms because the water is much cooler on the west coast of the United States. The water is flowing down from Alaska along the west coast and it's cooler. Whereas on the east coast in the Atlantic, you got warm Gulf Stream waters feeding the tropical storms and hurricanes.